In this first video, we're going to be looking at how to use exponential and logarithmic rules to solve algebraically for a few equations. This is the first part of your booklet. Before we do anything else, I think the first thing we should be doing is looking at our rules here. And I think really to start off with, I think you probably know all of these rules quite well, all right? So we're not going to spend much time on them. So I think that's something you've already done. What I do think we should do is spend a bit of time looking at these other rules. Now, these we've sort of talked about already quite a lot. They're on your first cheat sheet. I think it might be good to talk about logs in general first, okay? So maybe just put here, what I might do is just start off with an expression. So if I just say a to the x equals b, all right, you need to realize you can rewrite that as a logarithm, okay? So what we do is we have log in the base number. So in this case here, the base number is a. If the answer is b, then the logarithm or power must be x, okay? And this sort of thing highlights why we have logarithms. The reason why we have logarithms is they enable us to focus on the power, the logarithm, which in this case is x. Okay, so you just need to remember that any exponential sort of equation can be rewritten as a logarithm, okay, where a is the base number, so that's log base a, b is like the answer, and x is the logarithm or the power, okay? So when we look at these rules over here, you need to realize we spend all our time with e and the natural log, okay? So e is a number that's roughly 2.7. But if you're looking at this one here, we can use that power rule where you put n out the front. So it's really like the same as n times ln e. Okay, I might just write that over here, n times ln e. And just like I was saying before, ln, another way to write it is log base e, all right? And if you think about that here, it is actually written a little lower. Here it is here, all right, but it might need some explanation. Log e is actually equal to 1, because if you think about it, here's the base number, okay? There's the base. If it gives us an answer of e, what must have been the logarithm or the power is 1, okay? So what you need to realize is this whole part here can be equal to 1. So n times 1 is just going to be equal to n, okay? So that's what we've got there in that one. Another rule that they have here is ln e. All right, so ln e, I guess if we write it as log base e1 is equal to 0. Let's see if that does make sense. Here's the base, e. The answer is 1. What must have been the logarithm or the power? Well, yep, it had to be 0, didn't it? Okay. So when we see ln1, in actual fact, it could be any logarithm. It could be log 10, 1. It could be log 2, 1. All of those are going to equal 0 for that same reason. Okay, another couple of rules we've got up here. We've got ln 1 on a equals minus ln a. Another way to write that is ln a to the minus 1. The negative goes out the front, and that's why it becomes minus ln a. This is the one we just talked about. We know that's equal to 1. This one here is a bit of a special one. E to the ln a is always equal to a. It's actually to do with inverses, okay? You just need to realize that e, ln, anything in here, okay? Doesn't matter what it is, the answer will be anything. And it goes for any type of base number. You know, you could have 2 to the log base 2x, and that will equal x, or anything else that's written up the top there. All right, so I'll just rub them off just to make that a bit more tidier. And we'll have a look at using those questions over here. So we've got some rearranging techniques to start with underneath in example 1. Okay, you may not have seen this before, but it says write as a natural logarithmic equation. Now, really, all they're saying is, what that really means is just take the log of both sides and tidy it up. So hopefully you can remember that technique of taking the log of both sides. So we'll take the natural log, maybe I'll call it log base e. So whatever's written on this side sort of goes inside the brackets or the answer. And then I'll have log base e, a, e to the kt. All right. So you can actually break these down even further. You can't really do much with that side. I might just write it as ln. It's a lot more tidier writing like that. But I hope you can see here that you've got a times e to the kt. So using your log law of that, we know that ln ab equals ln a plus ln b, we can rewrite that. So I could actually, and we might, rather than writing log e, we'll just write ln from now. So I've got ln a plus ln e to the kt. And you can use that other rule where we know that ln a to the n, actually you can put the n out the front. It's ln a. Okay, so I could rewrite this as ln m equals ln a plus kt times ln e. And there's still more you could do. If you remember just up above here, we know that ln e is equal to 1, right? So that's actually equal to 1. So you really don't even need to write that. And generally, we just learn to write them like this because we like to isolate the variable. In this case, it's t. And that's why they ask you to write them like that. Okay, we've got a second one here saying write an exponent form. So another way you can write these is it's sort of like take the power of both sides. All right, so we normally use e. So I'm just going to do that here. So I'm going to put e, and whatever's over on this left-hand side becomes the power. Okay, now that means approximate, that sign there. So I do e to whatever is on this side. Okay. Now, one of the rules above here, this is that inverse law thing. So I've got e to the ln. It just becomes whatever's inside. Now, you can just use your rules of powers, that we know that a to the m plus n is actually the same as a to the m times a to the n. Okay, and we can just break that up. So it's really e to the 2.136 times e to the 0.385t. Okay, and there is a reason why they do that, because normally what they want to do is, this is actually a constant, so they want to isolate it. So normally we want to have a variable equal to a constant times by e to the x or t, some form of t. All right, now I'm going quick, so remember you can pause at any time. And we'll just go through these other examples. And this is really why we have logarithms a lot of the time, is we want to look at the power. So we actually want to work out what that x is in that case. So what we're going to do in this question is we take the log of both sides, okay? Because it's e, we take the natural log. I'll show you why. Now, I'll write the natural log as log e, in this case, if you want. So remember, whatever's written on the left goes in the bracket, and whatever's on the right goes in that bracket too. Now, you know that the power of x can go out the front. So you've got log e equals log e7. And I hope you guys can remember now that, this is like saying if your base number is e and the answer is e, what must have been the logarithm or power? It's 1. So that we know that all there can equal 1. Okay, so I'm just going to write that in there. So it's really x times 1. And so that will give us an answer of x equal to, and I'm just going to tidy it up and just write ln7. Okay, so just remember log base e is actually the same as ln. And yeah, I might start using that notation from now on. I hope that's okay. This next question is quite a little challenge. It's hard to spot. Most people can't spot what to do with it, but it actually becomes a quadratic. I think the easiest way to spot that it is a quadratic is if I write this second part as a positive indice. So you got x on the bottom. So what we do is we multiply everything by e to the x. So if you multiply everything by e to the x, you'll get e to the x all squared plus 2 lots of e to the x. Take 15 equals 0. Now that will just become 15. I've just put it on the other side. So when you see something like that, the reason why it's quadratic is you might not see it, but I'll just call it a letter. If you let e to the x equal a letter, you've really got a squared plus 2a take 15 equals 0, right? So we can factorize that now. So you've got a, what have we got, plus 5, a take 3 equals 0. We're going to run out of space, so I'm just going to put the rest down here. So to work out the rest of that question, you'll get either a is equal to minus 5 or a is equal to 3. Now we'll just replace the e to the x where a is. Now this e to the x equals 3 is very similar to the other one. If we just take the natural log of both sides, and you should realize the x will go out the front, and you'll be left with ln e, so it's just 1. So it's just going to be x equals ln3. This one, however, we might not be too sure about. You just need to realize that as long as this base number is positive, and we might just write that underneath here, provided that that base number is positive, this thing is never, ever negative, okay? I could just write provided A is positive as well. Okay, so it's never, ever negative. So in actual case here, we've got a sort of a false statement, okay? Or you can just say no solution, okay? And we do get that sometimes. I think you've experienced that a few times already. So you just need to realize that when you're answering that question, and it was the previous question, the answer, you only get one answer, and that answer is x is equal to ln3. Let's just check I've answered that whole question. Yeah, it just says find x. So we've just done that there. Okay, so I'll just need to rub that out, and I'll need to answer, start the next question in here as well. The next one is very similar, so you might want to actually stop and pause it at some stage because it is really actually another quadratic, okay? And you can maybe try and finish it yourself. So we want to find a point of intersection. So when we find a point of intersection, we know that they both share the same y value. So I'm going to say that the y value for the first equation will be the same as the y value for the next. Maybe writing it without negative indices might make more sense. All right. If I times both sides by e to the x, you'll be left with, this will become e to the x all squared. This will be just take 3e to the x equals 1. So that's 1 times e to the x. So that just becomes e to the x, take 3. Now if I put all of that over the other side, I'll get e to the x all squared. Take 3x, take another x will be take 4e to the x. And then I've got plus 3 equals 0. So if you let a equal e to the x, you would have a squared take 4a plus 3 equals 0. We get a positive value but when we multiply, but a negative when we add, so they both have to be negative in this case. And so you'll get a take 3 equals 0, so you get a equals 3 or a equals 1. Now let's replace a with e to the x, so we get e to the x is equal to 3 or e to the x equals 1. So in this case here, this one you don't even really need to think about. You should realize that just x will be 0, will be valid here, because the only way you're going to get 1 is if your power is 0. Now remember, you actually are asking for you to do the points. Okay, so I need to sub back in. It doesn't matter which one you're going to sub into. I would suggest you sub into the first one because it's a bit more simpler. So if you sub in 0 for x here, you get e to the naught is 1. 1 take 3 is minus 2. All right. The second one, if we can do that, if you take the natural log of both sides, you'll get ln equal to x equals ln3. Okay, so you would just get x equals ln3. So the points here would be ln3, comma, and I might have to do it on the side here, but if you sub this into this equation here, I'll just do it above, guys. So if you go e to the ln3, take 3. Remember that inverse law? E to the ln just becomes whatever's inside. And then you subtract 3, you get 0. Okay? So I know it's a bit quick, but we're just trying to put the solutions in as quick as possible there. All right, so you could check that using technology. So, if you don't know what ln3 is, you get your calculator out, press ln3, write it down, and then you go to the graph and you find the intersection and just check that it's the same. So there should be 2 intersections of those graphs. Oops. All right, let's go to the next example. So it says here, use log laws to write as a single logarithm. And the thing that's tricky here is we're not sure what to do when you get a single number. So what you're trying to do here is you're trying to sort of have something like this, all right? So you want 2 logarithms. They've got to be in the same base number. These are both natural log, because you know that you can use this log law where you can multiply those 2 things inside, all right? So at the moment, you've got a number and a logarithm. But what I hope you remember from one of the rules above is we know what we can write 1 is as a logarithm. And I'll just write it underneath. So you've got 2 ln5 plus 2 times ln e, okay? So we know that, if you're not too sure, ln is log e, all right? So if my base number is e and the answer is e, the logarithm would have had to be 1, Okay, so we've actually now know that 1 can be replaced as a logarithm expression. Now that they're both logarithms in base e, okay, I can add. And the important thing here is you need to realize that when you're using that log law, there is no number out the front. So if there's numbers out the front, you have to sort of reverse that power rule. So we really got ln 25, because 5 squared is 25, plus ln e squared. Okay, can't do much with that. And now we can use that log law finally, where we just multiply those two answers inside there. Okay. Next one, I think, is a little more self-explanatory. I think this one here, you just, like we said before, you've got to move the powers. So put that up there. So you've got ln x squared plus ln 5 cubed. Okay, the 3 is going to go up there as well. And then you can put them directly together. There's nothing else at the front. So you've really got x squared, 5 cubed. If you're really good, you could turn that into 125. All right. There are reasons why we do that. Okay. Now let's look at the last couple of examples here. We've got find without using a calculator the exact value of, right? So not really sure how to do that. It depends on how you learnt it last year. Some of you might know the answer is 3 straight away. I guess one way you could do that is you could put the 3 out the front, and hopefully you're getting better at recognizing this. But if I've got ln e, that's actually the same as 1. So I've actually calculated a specific value for it. Now, the second one, this is that inverse law. So the inverse law sort of looks like this, where whatever's in here inside the bracket is actually the answer. You must note here, though, there is nothing out the front, okay? Now, in this case here, you can see there's a 3 out the front, right? So what we've got to do is use our log law and put that back in, okay? So we put that back in. So really what you've got is e to the ln 8. And once you've got that there, the answer will just straight out be 8, okay? And just as a note, I know it's not here, but you just need to realize that it could be, anything up here, right? So the answer to e to the ln x squared plus 3x is x squared plus 3x, okay? But yeah, you must remember there cannot be a number out there, just like I have in this red bit out here, all right? Okay, last 2 examples to go through. All right, and these are not too bad. We've got to solve a logarithm expression. Now, generally in these types of questions, what you're trying to do is try and have something like that equal to this. And I reckon most of you will be able to use common sense there. You should be able to go, well, x must equal 5, okay? So what we're going to do is, like we just did before, we're going to try and collect these and write them as one logarithm. And so that once we get one logarithm on one side, we're going to then let it equal the thing on the other side. So x must equal 5. A little more complexity, but same idea. All right, so in saying that, let's put those first 2 together. We've got an addition, so that means we multiply the 2 things inside. All right, so now we can actually say that the thing inside there must equal the thing there. Let's expand that out. So we've got x squared take 3x. You know what? Let's take the 4 as well. We've got a quadratic. This actually doesn't look too bad, does it? So we've got x. What have we got? X take 4, x plus 1 equal to 0. And so you'll either get x equals 4 or x equals minus 1. Okay, so just double checking there. We just factorize that guy. So 2 numbers that multiply give us -4, that add to be -3 would be -4 and 1. And then solving, we get those values. It is a bit of a trick here, though, and might need a bit more understanding of logarithms to do this, but you should check all those values. So you see this first one here, you sub it in. So I know it sounds weird, but if you check ln 4 is okay, ln 4 take 3 gives us 1, so ln 1 is okay. Ln 1 is actually equal to 0, so that answer's fine, okay? But the second answer, I'm not too sure about. If we sub in -1, -1 take 3 is negative. In actual fact, it's negative there too, all right? We haven't really come across that yet, but I guess just talking about it in general, if I have a negative in here, let's try and think about, so that's what we'd have. We'd have ln -1 plus -1 take 3, ln -4. Let's see if that makes sense. So let's rewrite it as log base e negative. So what we're trying to say here is if the base number is e and our answer is negative, right, what must have been the logarithmal power? And this comes across as another rule. We need to realize that, you know what, that's nonsense. It doesn't work. Okay, we just talked about that. We said that earlier where this and that is always greater than 0. Okay, you just need to realize that it's in a logarithm expression. All right. So I guess what I'm going to do is write a little rule there. I guess we'll cross it out. We'll say it's no good. But for ln x, that thing cannot be negative. Okay. It can't actually be 0 either. That's something we can look at a bit later. Okay, so here's a question where we don't get a valid solution. So let's check this next one. So subtraction, we haven't had one of those before. Remember, that's division. All right. So it just means we've got ln 2x plus 12 all over x, okay, equals ln 4. Okay, so remember when we add, we multiply the two things inside. When it's subtract, we divide. So we know that this thing inside must equal this thing inside. So in actual fact, you're going to have something that's quite simple here, equals 4x. Maybe we'll subtract 2x to both sides, so you get 2x equals 12. You'll get x equals 6. Okay, and let's just check that 6 value in here. What's that? 2 times 6 is 12. 12 plus 12 is 24. Yeah, ln 24 is okay. Ln 6 is okay. Yeah, so you just got to realize there's some places we can't do that. All right. Yeah, so that's those first ones. I know that was quite quick, but hopefully that makes a bit more sense to you. So you've got a booklet to go through to practice those questions. All right, that's the end of that video. Thank you.